Hello everyone, welcome to Easy Maths. So in our previous part of tutorial about differentiation, we learned about tangents and normals, and also we learned to calculate the gradients of curves and functions. We figured out that the gradient of a curve at any point is defined as the gradient of the tangent to the curve at that point and measures the rate of increase of y with respect to x. We also learned that when b goes to a, the limit of gradient of chord AB equals to gradient of tangent AT. So in this tutorial, we are going to learn about general differentiation and equations of tangents and normals. Under general differentiation, we are going to find out the differentiation of a constant, differentiation of ax where a is a constant, differentiation of x to the power n, and differentiation of ax to the power n. General differentiation. Consider any curve y equals f of x. So the curve is shown in this diagram. Let a, x comma f of x be any point on y equals f of x. Let delta x be the increase in the x coordinate in moving from a to another point b on the same curve. So b is the point x plus delta x comma f of x plus delta x. Let delta y be the corresponding increase in the y coordinate in moving from a to b. That is, delta y equals f of x plus delta x, take away f of x. So if you look at this diagram, AB is any chord such that A has x comma f of x and B has x plus delta x and f of x plus delta x. Delta x is the increment in the x coordinate and delta y is the corresponding increment in the y coordinate. So the gradient of AB equals the increase in y over increase in x, which equals to delta y over delta x. So delta y equals f of x plus delta x take away f of x over delta x. Therefore the gradient at A is limit of delta y over delta x where delta x goes to 0 equals limit of f of x plus delta x take away f of x over delta x where delta x goes to 0. So we know that the gradient of any curve is given by dy by dx, that is limit of delta y over delta x where delta x goes to 0. Or we can say differentiation of f of x with respect to x equals limit of f of x plus delta x take away f of x over delta x. This formal definition of differentiation can be used to differentiate any function that have not yet met. This process is called differentiating from first principles. Fortunately, it is not always necessary to go back to first principles because certain categories of function can be differentiated by rules, some of which we will now find. Which means you don't need to go with the first principles all the time. We can use some of the rules for differentiation. So the first rule is differentiation of a constant. Consider the equation y equals c. This represents a straight line parallel to the x-axis and so it has zero gradient. Since the curve is y equals to c, it cuts the y-axis at x equals 0 and also it has a gradient of 0. So dy by dx equals 0, or we can say derivative of c with respect to x equals 0. So any constant differentiated with respect to x equals 0. Differentiation of ax where a is a constant. Consider the equation y equals ax. This represents a straight line with gradient a. That is dy by dx equals a, or derivative of ax with respect to x equals a. So the next rule of differentiation is differentiation of x to the power n. The table below summarizes the results for some of the questions in exercise 1b, which we had in our differentiation part 1 tutorial. So if you look at the table, f of x and derivative of the f of x with respect to x is given. X squared would give us 2x, x cubed would give us 3x squared, x to the power 4 gives us 4x cubed, and x to the power negative 2, which equals to 1 over x squared, equals negative 2x to the power negative 3. From the table, it appears that to differentiate a power of x, we multiply by the power and then subtract 1 from the power. That is, derivative of x to the power n with respect to x gives us n x to the power n take away 1, which is equation 1. This result, deduced from a few examples, is in fact valid for all powers of x, including fractional and negative powers. Although proof is not possible at this stage, this is one example of many such rules whose validity for the time being we must take on trust. So the rule number 1 can be used for any powers, including fractional and negative powers. Accepting that rule 1 above can be used for any power of x, the following examples illustrate its application. Example. So derivative of x to the power 9 with respect to x equals 9x to the power 8. Derivative of x to the power negative 4 with respect to x gives negative 4 times x to the power negative 4 take away 1, which gives us negative 4x to the power negative 5. Derivative of root of x with respect to x equals derivative of x to the power 1 half with respect to x. So when we derive x to the power 1 half with respect to x, we get 1 half times x to the power 1 half take away 1, which equals to 1 half times x to the power negative 1 half. So when we derive a power of x, we multiply by that power and then we subtract 1 from the power. So when you look at the example derivation of x to the power 1 half, we times by the power which is half and then we take away 1 from the power which is 1 half take away 1. So the result is 1 half times x to the power negative 1 half. So that happens for each of these examples. So we multiply by the power and then we subtract 1 from the power. Now try out these questions by yourself. Differentiate by rule the following with respect to x. So we have x to the power 5, x to the power negative 3, x to the power 1/3, 1 over root of x, and then cubic root of x squared. So if you try out these questions, you will get answers like this. So when you derive x to the power 5 with respect to x, we multiply by the power and then subtract 1 from the power. So we get 5 times x to the power 4. And when you work out differentiation of x to the power negative 3 with respect to x, so we multiply by the power which is negative 3 and then we take away 1 from the power which is negative 3 take away 1. So we get negative 3 times x to the power negative 4. Similarly, when x to the power 1/3 is derived with respect to x, we get 1/3 times x to the power 1/3 take away 1, which is 1/3 times x to the power negative 2/3. So when we work out the derivation of 1 over root x, 1 over root x can be written as x to the power negative 1 half, because root x can be written as x to the power half. So as the root x is at the denominator, when we take it to the numerator, it becomes negative 1 half. So derivation of x to the power negative 1 half gives times by the power which is negative 1 half, and then we take away 1 from the power which is negative 1 half take away 1. So we'll be getting 1 half times x to the power negative 3 halves. When cubic root of x squared is derived with respect to x, first we convert. So we get x to the power 2/3. So this is because a denominator of 3, as it is the cubic root of x squared. So the 2 comes as the numerator and the 3 comes as the denominator. So when it is differentiated, we get 2/3 times x to the power 2/3 take away 1, which would give us 2/3 times x to the power negative 1/3. So the next rule is differentiation of ax to the power n. Selecting some more results from exercise 1b, we see that derivative of 3x squared to the respect to x gives us 3 times 2x. So we multiply by the power and then we subtract 1 from the power, so which would give us 3 times 2x. Similarly, we get 5 times 3x squared for the derivation of 5x cubed with respect to x. So these results suggest that derivative of ax to the power n with respect to x gives us a times derivative of x to the power n with respect to x equals a n x to the power n take away 1. So if you look at this expression, a is a constant like 3 and 5, and x to the power n is the term which has power. So we can take the a out of the derivative, and then we can derive the term with the power, so that we'll be getting a n x to the power n take away 1. So here we are getting n because of the rule where when we derive a power of x, we multiply by that power and then we take away 1 from that power. So again, selecting from exercise 1b, we have derivative of x squared plus 3x with respect to x gives us 2x at plus 3. So we can consider the derivative of each of the terms, x squared and then 3x. So when we separately derive them, we get 2x at 3. So the same way we do it for the next expression also. So when we derive x squared take away 2x plus 1 with respect to x, we get 2x take away 2. Since 1 is a constant, it becomes 0 when we derive it with respect to x, as there is no any x in the term 2. So the answer would be 2x take away 2. So this suggests that the operation differentiate is distributive across addition and subtraction of fractions. That is, differentiation of f of x plus g of x with respect to x gives us differentiation of f of x plus differentiation of g of x with respect to x. So we distribute f of x at 3 of x into two separate terms, and then we differentiate separately. So that's why we call differentiation is distributive across addition and subtraction of fractions. But this is not true for multiplication and division. So that is the third equation which we get, which can be used in exercises. Therefore, derivative of 3x squared take away 7x with respect to x gives us 3 times 2x take away 7, which is 6x take away 7. And derivative of x plus 1 over x with respect to x gives us derivative of x plus x to the power negative 1 with respect to x, which equals to 1 take away x to the power negative 2. So we get 1 when we derive x. So as we are deriving separately, so we get differentiation of x with respect to x at differentiation of x to the power negative 1 with respect to x. So when we differentiate x with respect to x, we get 1. Since the power of x is 1 in just x, x to the power negative 1 is differentiated with respect to x. We times by the power and then we take away 1 from the power. So that would give us negative x to the power negative 2. So that's how we get 1 take away x to the power negative 2 as the answer. So note that differentiation is not distributive across multiplication and differentiation. So differentiation of x times x take away 3 with respect to x gives us differentiation of x squared take away 3x with respect to x. So we have expanded the brackets and we got x squared take away 3x. Differentiating x squared take away 3x would give us 2x take away 3. But when we distribute x and x take away 3 and when we differentiate separately, we get the derivative of x with respect to x as 1, and the derivative of x take away 3 with respect to x would give us 1. So 1 times 1 is 1, which is not equal to 2x take away 3. So that means differentiation of x times x take away 3 with respect to x is not the same as differentiation of x with respect to x times the differentiation of x take away 3 with respect to x. So in order to differentiate at this stage, therefore any product must be expanded and any quotient must be divided by how to give terms which are added or subtracted. So if we get an expression like x times x take away 3, it is better to expand the expression as x squared take away 3x and then differentiate the terms separately. Example 2d. Differentiate f of x equivalent to 4x squared plus x take away 1 over 2x. So the function of f of x is 4x squared plus x take away 1 over 2x. So by simplifying the expression we get for x squared over 2x at x over 2x take away 1 over 2x. So we get such an expression because 2x is the common denominator for each of the terms for x squared, x, and -1. So that's how we distributed the expression into separate terms. So therefore f of x becomes 2x plus 1 half take away 1 half x to the power -1. So we got the 2x by dividing 4x squared by 2x, and then x over 1 half would give us just 1 half because we just cancel off 1x from the top and the bottom. So we get 2x when we divide 4x squared by 2x. So 4 divided by 2 is 2, and x squared divided by x would give us x. Similarly, we divide the top term by the bottom term, which would give us 1 half. And then we take the x to the top, which is x to the power -1. We get the expression as 2x plus 1 half take away 1 half x to the power -1. Therefore, derivative of f of x would give us 2 at 0, since 1 half is a constant. Take away 1 half times negative x to the power -2. So we times by the power and then take away 1 from the power, so that would give us negative x to the power -2, which equals to 2 at 1 half x to the power -2, which is simplified to get 2 plus 1 over 2x squared. Moving on to the next question. Find the gradient of the curve y equals x take away 3 times x squared plus 2 at the point on the curve where x equals 1. So the equation y equals x take away 3 times x squared plus 2 can also be written as y equals x cubed take away 3x squared plus 2x take away 6. So when we expand the brackets, we get x cubed take away 3x squared plus 2x take away 6. So therefore, the derivative of y with respect to x would give us 3x squared take away 6x plus 2. Since there is x cubed, we times by the power and then we take away 1 from the power, which would give us 3x squared, and then take away 3 times the power would give us 6. Take away 1 from the power would give us 1, so x to the power 1. Then it becomes negative 6x plus 2 is a constant with the x term, so that we get 2 at the end. 6 is a constant without any x terms, so it becomes 0 when we derive negative 6 with respect to x. So when x equals 1, as we are asked to find the curve at x equals 1, we substitute x equals 1 in the gradient of the curve, which would give us 3 times 1 squared take away 6 times 1 plus 2. So simplifying the calculation would give us -1 as the answer. Therefore, the gradient of y equals x take away 3 times x squared plus 2 is -1 at the point where x equals 1. Find the coordinates of the point on the curve y equals 2 over x squared at which its gradient is 1 half. So we are asked to find the point on the curve where the gradient is 1 half. So y equals 2 over x squared can be written as 2 times x to the power -2. Since the denominator is x squared, we take it to the top. We get a negative power. So dy by dx, which is the gradient of a curve, equals -4x to the power -3. Since we times by the power and take away 1 from the power. So now we have two values for the gradient. When we equate those two values, we get -4x to the power -3 equals 1 half. And by taking the x to the power -3 to the denominator, we get -4 over x cubed equals to 1 half. By cross multiplication, we get x cubed equals -8. So we need to find the cubic root of -8, which becomes -2. So x equals -2. At the point on y equals 2 over x squared, where the gradient is 1 half, the x coordinate is -2, and when x equals -2, the y equals 1 half. Therefore, the gradient of y equals 2 over x squared is 1 half at the point -2, 1 half. Exercise 2D. Differentiate with respect to x. 3x squared take away 7x. X cubed plus 2 over x. So now try out these questions by ourselves. So first we consider y equals 3x squared take away 7x. Then if we differentiate with respect to x, we get 6x take away 7. So we multiply by the power and then take away 1 from the power. And negative 7x differentiated with respect to x gives us negative 7. If you differentiate x cubed plus 2 by x with respect to x, we get, so first we consider y equals to x cubed plus 2 over x, and we distribute, and if we divide x cubed by x, we get x squared, and 2 over x can be written as 2x to the power negative 1. Then if we differentiate y with respect to x, we get 2x take away 2x to the power negative 2. So when x squared is differentiated with respect to x, so 2 is multiplied and 1 is taken away from the power. So that's how we got 2x here. Similarly, negative 1 is multiplied with the 2, so we get negative 2, and 1 is taken away from the power, which gives us x to the power negative 2. So we get 2x take away 2x to the power negative 2, and 2 is common for both the terms, so we take 2 out of the brackets. So the answer is 2 bracket x take away 1 over x squared. So x to the power negative 2 can be written as 1 over x squared. Find the gradient of the given curve at the given point on the curve. Y equals x squared take away 3, where x equals 1. So the point is where you get x equals 1. And the second question is y equals x take away 3 times x plus 4. So the point where we need to find the gradient is at x equals negative 1. So if you work out the first question, we get dy by dx equals 2x. The point is at x equals 1, so therefore dy by dx equals 2 times 1, which is 2. So we can say the gradient of the given curve is 2 at the given point where x equals 1. Similarly, when you work out the second question, we find that y equals x take away 3 times x plus 4. So we can simplify by taking off the brackets, which is x squared plus x take away 12. And by differentiating with respect to x, we get 2x plus 1. As the point is at negative 1, we substitute negative 1 instead of x in the dy by dx. So we get 2 times negative 1 plus 1, which is negative 2 plus 1 equals negative 1. Find the coordinates of the point or points on the given curve at which its gradient has the given value. So the equation of the curve is given, and we are asked to find the coordinates on the given curve at which the gradient has the given value of 1. So dy by dx equals 2x take away 1, and the given point, and the gradient has a given value of 1. So we have an expression for dy by dx, and also we have a value for dy by dx. So we equate both of them, and we get 2x take away 1 equals 1, and by bringing the 1 on this side, on the other side, we get 2x equals 2. And by dividing both the sides by 2, we get x equals 1. So at the point on y equals x squared take away x plus 3, where the gradient is 1, the x coordinate is 1, and when x equals 1, y equals 3. So we got y equals 3 because we substituted x equals 1 in the equation y equals x squared take away x plus 3. So if you substitute 1, you get 1 squared take away 1 plus 3, which equals to 3. Therefore, the gradient of y equals x squared take away x plus 3 is 1 at the point 1, 3. Y equals root of x. So the gradient value is given as 2. So y equals root of x, and root of x can be written as x to the power 1/2. So dy by dx equals 1/2 times x to the power 1/2 take away 1. Where we have done the multiplication of the power and taking away 1 from the power. So by simplifying the calculation in the power, we get 1/2 x to the power negative 1/2. And we have the dy by dx value, which is 2. So we equate the expression and the value, which is 1/2 x to the power negative half equals 2. And by multiplying both the sides by 2, we get 1 over root x equals 4. So we got 1 over root x because x to the power negative 1/2 can be written as 1 over root x. And by cross multiplication, we can get root x equals 1 over 4. As we need to find out the value for x, we need to find the square of both the sides so that we get the value of x. So x equals 1 over 4 squared, 1 over 4 whole thing square, which is x equals 1 over 16. So at the point on y equals root of x, where the gradient is 2, then the coordinate is 1 over 16. And when x equals 1 over 16, y equals 1 over 4. Therefore, the gradient of y equals root of x is 2 at the point 1 over 16, 1 over 4. Equations of tangents and normal. Now that we know how to find the gradient of a curve at a given point on the curve, we can find the equation of the tangent or normal to the curve at that point. So we know that normal is perpendicular to the tangent. So using that information, we are going to figure out the answer for these questions. So examples 2e, find the equation of the tangent to the curve y equals x squared take away 3x plus 2 at the point where it cuts the y-axis. So if the curve is cutting the y-axis, the x-coordinate of the y-axis is 0. So y equals x squared take away 3x plus 2 cuts the y-axis where x equals 0. So when we substitute x equals 0 in the equation y equals x squared take away 3x plus 2, we get 2 for y. The gradient of the tangent at 0, 2 is the value of dy by dx when x equals 0. So we got the gradient of the tangent at the point 0, 2. So that is where the curve cuts the y-axis. So as y equals x squared take away 3x plus 2, dy by dx equals 2x take away 3. When x equals 0, the gradient of the curve is negative 3. So we substitute 0 for x in the gradient of the curve, which is 2x take away 3. So we got the answer as negative 3 by substituting x equals 0. So therefore the tangent has gradient of negative 3 and passes through 0, 2. So its equation is y equals negative 3x plus 2. So we got the equation of the tangent as y equals negative 3x plus 2 because the general equation for a straight line is y equals mx plus c. So m is the gradient and c is the intercept. So we know the gradient is negative 3 and the intercept is 2 because the curve is cutting the y-axis at y equals 2. So that is 3x plus y take away 2 equals 0. So that's it for this tutorial. I hope you enjoyed learning about general differentiation, where we learned about differentiation of a constant, differentiation of ax where ax a constant, differentiation of x to the power n, and differentiation of ax to the power n. So any constant differentiated with respect to x is 0, and we found when ax is differentiated with respect to x gave us a as the power of x is 1, and the differentiation of x to the power n would give us nx to the power n take away 1, which is we multiply the power and take away 1 from the power. And the differentiation of 8x to the power n give us anx to the power n take away 1. And also we learnt about equations of tangents and normals. So we'll be giving you more questions and explanations in our upcoming tutorials, and also use the links given in the description to practice more on differentiation. So for all of that and more, I'll meet you in the next tutorial.